Hello, you made it this far. Learning target number 3, algebra, another important idea. For some reason, we haven't done enough with percents. This is saying like percent increase or percent decrease. So let's do a little flex right here. Got some cash. Got a little action here. A little 20, 40, 50. 55, 60, 1, 2, 3, 4, $64 on the button. Where's all my Nintendo 64 fans at? Anyway, so $64. Let's just talk about this for 1 second. This is all of the cash I have on me, all of it. I got 64 bones on me. So we have to set that reference. This reference in my pocket, going to spend on some more games eventually. $64, that's 100% of my cash. That's all the cash I have. I have no cash anywhere, I have no cash in my bag, no cash in my drawers, nowhere. This is the cash I have in my pocket to my name, cash. Got stuff in the bank, all that stuff, Apple Card, you know what's up, but cash on me, $64. So $64 is 100% of my cash, okay, $64. So if I wanted to say something weird like I need to increase said cash by 50%, I want a 50% increase in my money. So I want more than I have right now. I want more than my 100%. I think all of you can do the math on this. 50% or half of my money would be what? $32. So I want to increase my money by 50%. I want to increase it by half. I want to increase it $32. I'm gonna have the answer of $96, right? Because I put those together, right? 64 plus that half of my money. If I put that together, that'd be $96. Well, think about this for a second. Didn't I just put those percents together? So I can think about that as $96 is 150% of my money, or I could say separately, I increased it by 50% over the 100%, or as the decimal, right, with percents, those little guys remind you always move it twice, right? So as a decimal, that'd be 1.5 times the amount of money I had, okay? So giving it a little algebra geometry here, the base of an isosceles triangle, I know that. Isosceles triangle, boom, draw it, okay? Is 35% longer than the legs. Oh, the base is longer than the legs. So this is a bad drawing, right? Okay, so I need something like this, isosceles, but then I need the bottom to be longer, okay? Than either of the legs. So it's 35% longer, but what is it in comparison to the legs? So the legs are the 100% in this problem. They're the original starting amount, which I don't know. I don't know that, so I'm just going to call it X. So that leg is, of course, also X. And the only other number they gave me is that the perimeter, the distance around the triangle, is 67 feet. So I know the leg plus the base is 67. Okay, so 3 unknowns, but I know one tiny little bit of detail. So the legs are the original, the X is 100%. They want me to increase that 35%. And again, we think about when we're calculating as a decimal, so 35% would be like 35 cents or 0.35. So I want to increase it by 35% of that. Well, if I think about this 1x as being my one whole, I essentially have 1x plus 35% of an x. So it would be 1.35, right? 35% above 100, 35 cents above $1. So I know if I do 1.35 times x, that would be how long that base is, over 100%. Well, now, at least I have all three sides of this triangle labeled. So I would do x plus 1.35x. So that would be x 1.35x. All of that added together equals 67. So 1x, so 3.35x equals 67. All right. So I don't have my calculator on me, but what you would do is just divide by 3.35. Find out what x is, that would be both the legs, and then plug it back in to see how much longer that base is, and then you would have each of the legs, okay? So that's percent increase. You are either adding to 1 if it's increasing, 1 whole 100%, or you're subtracting from 1 whole 100% if it's decreasing, all right? But we know we're gonna have that money increasing